Hello, grade 10s. Welcome back to the channel. In today's lesson, we're going to be looking at algebra, factorizing in fractions. So I know a lot of you get anxious when you see those questions that are in fractions, but from today on, worry no more because I'll be clarifying that and giving you a simple and very easy strategy to tackling those questions. And let's get right into the lesson. Ra! So let's look at our first example. We have a squared minus b squared over 5a minus 5. And we can see that this is factorizing in fractions. So now when dealing with this question, the easy method is to deal with them separately. So you want to look at your numerator separately, deal with it, have the solutions to it, and then look at your denominator also separately, deal with it, and have solutions to it. Now, what we are actually gunning for here, or what we are aiming for, is that we have the same expression in the numerator and the denominator. So now we have a squared minus b squared, which we can see that this is difference in two squares because all our variables are squared, and then we can see there's a minus sign in between those two terms, and also there is no middle term, right? So factorizing that one, we can open two brackets and start to distribute our variables evenly. So we have a here and a there, and we have b here and b there. So since this is difference of two squares, we know the signs are not the same. Let's have a minus this side and have a positive on that other bracket. And then now we want to look at the denominator. With the denominator, we can see that this is factorizing, but factorizing by factoring out the common factor, right? So we can see we have 5a and the second term is 5. What is common between these two terms? 5, right? So in this first term, if we factor out 5, we are only left with a. And in the second term, when we factor out 5, we are only left with minus b, right? So remember, we said we are aiming to have that common expression in the numerator and denominator so that we can divide it out. So now, what is that common expression between the numerator and denominator? We can see that the common expression is a minus b, a minus b. So what does it do? Divide out, right? So now in the numerator, we are only left with a plus b, and in the denominator, we are left with 5. That becomes your solution. Now let's have a look at another example. Let's say this time we are given 4x squared minus 9 over 4x squared minus 6x. So again, we can see that we have difference of two squares in the numerator, whereby we can see that the 4 here is a perfect square, and also the 9 there is a perfect square. So what do we do with this one? That we open two brackets, right, in order to factorize that one. So now when we put 4 in a square root, it's supposed to give us 2, right? So we distribute that 2, but now it's 2x and 2x, right, because of that squared. Then when we put 9 in a square root, we have 3, so we distribute that 3, but this is difference of two squares, so the signs are not the same. That's minus 3 and that's plus 3, right? Then we say over. Now we want to look at the denominator. With the denominator, we can see again, this is factorizing, but by factoring out the common factor. So in terms of your coefficients, what is the common factor? What is that number that can go into 4 and 6 and give no remainder? So we have a common factor of 2. 2 can go into 4, 2 can also go into 6. But in terms of your variable, what is your common factor? It is x, right? So we have x in the first term, and we also have x in the second term. So now when factoring out 2x in the first term, we are left with 2x, right? So that's 4x squared divided by 2x, it gives us 2x. Then when we factor out 6x, what are we left with? So if we say 6x divided by 2x, we are left with 3, right? So it's negative 3 because it's negative 6, right? So once again, do we have a common expression in the numerator and the denominator? So we do have a common expression, that's 2x minus 3, also down here 2x minus 3. So they divide out. In the numerator, we are left with 2x plus 3, and in the denominator, we are only left with 2x, and you leave it like that. That's your final solution. Now let's have a look at another one. So let's say this time around we are given p squared minus 25 q squared over 3p squared minus 15p q, right? So we look at the numerator, and when we look at the numerator, we can see once again we have difference of two squares. Our 25 is a perfect square. So factorizing this one, we open two brackets, then we have p of p. Make sure to check my video on difference of two squares if you haven't seen it yet. Then this is 5q, and then this side we have 5q. Remember, 25 is a perfect square. It gives us 5, and 5 is repeated infinity. And then the signs are not the same, difference of two squares. Now, when we look at the denominator, we can see this is factorizing by taking out the common factor. So the common factor between 3 and 15, what is that number that can go into 3 and 15 and give no remainder? It is obviously 3, right? And then what is the common factor in terms of your variables? We have p on the first term and we also have p on the second term. So your common factor is 3p. So when we factor out 3p from 3p squared, we are only left with p, right? And then when we factor out 3p from 15pq, we'll be left with minus 5q, right? So that's like saying negative 15pq divided by 3p, it gives us negative 5q, right? Now we want that common expression between in your numerator and your denominator. So that's p minus 5q, right? So what does it do? Divide out. So plus 5q in the numerator, and we are only left with 3p in the top. Now let's have a look at this one. Let's say we are given a question like this now with a trinomial. Now, how do we solve one that has a trinomial and not difference of two squares? Now, with a trinomial, we know how to factorize trinomials. Again, we open two brackets, distribute the first term, x and x, right? And now we'll be looking for the factors of the last term, 4. The factors of 4 is 1, 2, and 4. So those are the factors of 4. Now we want two factors of 4. When you multiply them, they give you 4. When you add or subtract them, they give you 3. Now we can all agree that's 1 and 4. So if you say 1 times 4, that's 4. Say 1 minus 4, you get the negative 3 in the middle term. So we have 4, we have 1. But remember, our signs are guided by the middle term, right? So we say we take the sign of the middle term and assign it to the bigger factor, to the bigger number. So the bigger factor here is 4. So this is minus, and the other one has to be plus. Why do we have different signs? Remember, negative can only form as a result of multiplying two signs that are not the same. Now let's come to this one. For this one, we can see that we have 3x squared minus 3. Now this is factorizing by taking out the common factor. The common factor in that expression is 3. And then when we factor out 3, we are left with x squared. When we factor out 3 from this one, 3 divided by 3, we are only left with 1. Now we can see that we do not yet have the common expression in the numerator and the denominator. That means we can still go further. So taking the numerator as it is, let's now factorize this difference of two squares, x squared minus 1. So gives us x minus 1 and x plus 1. Now from this we can see that now the common factor between the numerator and denominator is x plus 1. So that divides out, and now the solution that we have is, let's write it here. Now we have in the numerator x minus 4, and in the denominator we have 3 bracket x minus 1. So that becomes your solution. Right. Let's look at another one that is a trinomial. So let's say now we have x squared plus 2x minus 8 over 2x squared minus 8. Now once again we are dealing with a trinomial, so we have to open two brackets. Then we have x and x. So now we are looking for the factors of the last term, 8. Factors of 8 are 1, 2, 4, and 8. Now what are two factors of 8? When you multiply them, they give you 8. When you add or subtract them, they give you 2. So we can all agree that's 2 and 4. If you say 2 times 4, you have 8. But if you say 4 minus 2, you have 2. So let's have 4, let's have 2. And once again, our signs are guided by the middle term. So the middle term is positive. We assign the sign of the middle term to the largest factor or the biggest factor. So that's plus 4, and this one will have minus 2. We do that because our last term is negative, and negative comes as a result of multiplying signs that are not the same. Now for the denominator, we have 2x squared minus 8. Factorizing by taking out the common factor. The common factor between 2 and 8 is 2. 2 can go into 2 and leave no remainder, and 2 can go into 8 and leave 3. So we have 2, and then when we factor out 2 from 2x squared, we are only left with x squared. When we factor 2 from negative 8, we are left with minus 4. So that's like saying negative 8 divided by 2. Again, we don't yet have a common factor between the numerator and denominator. So that means we need to still factorize further. So what can we factorize here? The denominator, which we can see this, the difference in two squares. So now we have x minus 2 and x plus 2. Now, do we have a common factor between the numerator and denominator? Yes, we do. It's x minus 2. So they divide out. Now we are left with x plus 4 over 2x plus 2. Right. Let's look at yet another one. Let's say now we have x squared plus 7x plus 12 over x squared plus x minus 6. So with this one, we can see that we are dividing two expressions that are trinomials. So what do? Open two sets of brackets. In the numerator, now we have x, and now we are looking for the factors of 12. The last term, it's 1, 2, 3, 4, 6, and 12. Now we want two factors of 12. When you multiply them, they give you 12. When you add them, they give you 7. So you have 4 and 3. Now, when you have a situation like this whereby your middle term and your last term are both positive, you know the signs that go in there will all be positive. So if you have your positive 4 multiplied by positive 3, it's positive 12. And also 4 plus 3 is positive 7. Now let's look at the denominator now. What is happening with the denominator? This is also a trinomial. So we open two sets of brackets. We have x here, x there. At this time, we are looking for the factors of 6. Factors of 6 are 1, 2, 3, and 6. Now we want two factors of 6. When you multiply them, they give you the last term. When you add or subtract them, they give you the middle term. Right. So when you multiply them, they give you 6. When you add or subtract them, they give you 1. So we obviously want to choose 2 and 3. So let's have 2 this side and let's have 3 that side. Remember, it doesn't matter. What matters are the correct signs. Now remember, we are guided by the middle term in terms of our signs. So because we have a positive and a negative here, we know in order to get a negative, we must have signs that are not the same. The positive will go to which factor here? That's to go to 3, because the sign of the middle term goes to the bigger number. Then this one is minus. Do we have a common factor in the numerator and denominator? Yes, we do. So divide out. And now our solution is x plus 4 over x minus 2. Let's look at the last one. Let's say now we have x squared minus 3x minus 10 over x squared minus 7x plus 10. So we open two sets of brackets. First in the numerator, then we distribute x and x. Now we are looking for the factors of the last term, 10. So what are the factors of 10? That's 1, 2, 5, and 10. So we want two factors of 10. When you multiply them, they give you 10. When you add or subtract them, they give you the middle term, 3. So we know that's going to be 2 and 5. So let's have our 5 here, our 2 there. Now what about the signs? The signs are guided by the middle term. The middle term is negative, so we assign the sign of the middle term to the bigger number. So that's -5, and here we have +2 over, again in the denominator we have a trinomial, so we have x and x. The last term is still the same as 10, so the factors of 10, 1, 2, 5, and 10. Now 2 factors of 10, when you multiply them, they give you 10. When you add or subtract them, they give you 7. Again, it's 5, 2. So we have 5 and 2. The signs are guided by the middle term. So your middle term is negative, but then look, the last term is positive. So we know the only way we have positive is when we have a positive and a positive, or negative times negative. Now, since our middle term is negative, we know we definitely have to have negative and negative in order to have the positive term. So if you say -5 times -2, you have +10. If you say -5 minus 2, we have -7. Do we have a common expression in the numerator and the denominator? Yes, we do. It's x minus 5 and x minus 5. So our solution is x plus 2 over x minus 2. That's how you have it. All the best. Keep on practicing. Remember, the more questions you practice, the easier it will become for you to solve this question. Right.